NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will learn how to rationalize denominators that contain cube roots. We will build intuition first, then apply the general rule to two clear examples. The key idea is to rename. Let x be the cube root of a, and y be the cube root of b. Then x cubed equals a, and y cubed equals b. Using this, we can connect to the sum and difference of cubes identities. Recall the identities. For a sum, left parenthesis x plus y right parenthesis times left parenthesis x squared minus x y plus y squared right parenthesis equals x cubed plus y cubed. For a difference, left parenthesis x minus y right parenthesis times left parenthesis x squared plus x y plus y squared right parenthesis equals x cubed minus y cubed. Substituting a and b, the denominators become a plus b or a minus b, which are rational. Rule for a plus case. If the denominator is cube root, a plus cube root b, multiply numerator and denominator by x squared minus x, y plus y squared, where x is cube root a and y is cube root b. The denominator turns into a plus b. Rule for a minus case. If the denominator is cube root a minus cube root b, multiply numerator and denominator by x squared plus x, y plus y squared. The denominator becomes a minus b. Example, rationalize the denominator of 1 over cube root 2 plus cube root 16. We take x equals cube root 2 and y equals cube root 16, which is 2 times cube root 2. Use the plus rule and multiply by x squared minus x, y plus y squared. Watch the denominator become a plus b. That is 2 plus 16 equals 18. Then simplify the numerator carefully. Second example, rationalize 1 over cube root 5 minus cube root 2. This is the minus case. Multiply by x squared plus x, y plus y squared. The denominator becomes a minus b, which is 5 minus 2 equals 3. The numerator is already rationalized, and we leave it in cube root form. Quick recap. For a plus sign, multiply by x squared minus x, y plus y squared, and the denominator becomes a plus b. For a minus sign, multiply by x squared plus x, y plus y squared, and the denominator becomes a minus b. These come straight from the sum and difference of cubes. You now have a reliable method to rationalize any denominator that is a sum or difference of cube roots. Practice with a few more pairs of numbers to build speed and confidence. In this lesson, we will rationalize a denominator that contains cube roots using a powerful identity. Our example problem is, rationalize the denominator of 2 divided by the cube root of 5 plus 1. Here is the key idea. For any numbers x and y, the product of x plus y, and x squared minus x, y plus y squared equals x cubed plus y cubed. This turns a sum of cube roots into ordinary numbers. In our problem, let x be the cube root of 5, and let y be 1. Then x cubed plus y cubed becomes 5 plus 1, which equals 6. To eliminate the cube roots in the denominator, multiply numerator and denominator by the companion expression x squared minus x, y plus y squared. That guarantees the denominator becomes x cubed plus y cubed. Now, apply this to our fraction. We multiply 2 over the cube root of 5 plus 1 by that companion fraction. Because the denominator is in the form x plus y times x squared minus x, y plus y squared, it simplifies to x cubed plus y cubed, which is 6. So the whole fraction becomes 2 times the companion expression, over 6. Now we can simplify 2 over 6 to 1 over 3. Final answer. We rationalized the denominator by using the sum of cubes identity. Remember, if the denominator is a plus b with cube roots, use the companion a squared minus ab plus b squared. If it were a minus b, we would use a squared plus ab plus b squared. Follows the plus version. We want to simplify the fraction open parenthesis x plus 8 close parenthesis over cube root of x plus 2. We set it equal to the cube root of x and b equal to 2. For a plus b, we multiply by a squared minus ab plus b squared over itself. In the denominator, we now have a plus b times a squared minus ab plus b squared, which collapses to a cubed plus b cubed. That equals x plus 8. Now x plus 8 cancels, leaving only the neat expression, cube root of x squared, minus 2 times cube root of x plus 4. Now, an example with a minus sign in the denominator. Simplify 1 divided by cube root of 7 minus cube root of 3. Use it equal to cube root of 7 and b equal to cube root of 3. For a minus b, multiply by a squared plus ab plus b squared over itself. The denominator becomes a cubed minus b cubed, which is 7 minus 3, equal to 4. In the numerator, we keep the 3 terms with cube roots. A quick visual to remember: the plus denominator uses minus ab in the helper factor. The minus denominator uses plus ab in the helper factor. Think of them as opposites that unlock the perfect cubes. In this video, we will rationalize denominators that contain cube roots. We will use the sum of cubes identity to build the right multiplier. Example: we will first rationalize 1 over the cube root of x squared plus 1. Then we will rationalize 1 over the cube root of 5 plus the cube root of 2. Rule reminder: to eliminate a cube root in a sum plus b, multiply by a squared minus ab plus b squared. This works because the product equals a cubed plus b cubed. Step 1. Identify a equals the cube root of x squared, and b equals 1. Multiply the fraction by a squared minus ab plus b squared over itself. Step 2. By the rule, the denominator becomes a cubed plus b cubed, which is x squared plus 1. In the numerator, distribute. You get the cube root of x to the 4th minus the cube root of x squared plus 1. That finishes the first rationalization. The denominator no longer has cube roots. Now, for the second fraction. Here, a equals the cube root of 5, and b equals the cube root of 2. Again, multiply by a squared minus ab plus b squared over itself. The denominator simplifies to 5 plus 2, which is 7. The numerator becomes the cube root of 25 plus the cube root of 4 minus the cube root of 10. Example: we start with a classic form that matches x squared plus x, y plus y squared in the denominator. Let x be the cube root of a, and y be the cube root of b. Problem: 1 over the cube root of a squared plus the cube root of ab plus the cube root of b squared. Step 1. Multiply by the special factor, the cube analog of a conjugate, the cube root of a minus the cube root of b over itself. This pairs with x squared plus xy plus y squared to produce x cubed minus y cubed in the denominator. Step 2. Apply the identity. The denominator becomes a minus b because the cube of the cube root of a is a, and the cube of the cube root of b is b. So the result is the cube root of a minus the cube root of b all over a minus b. Quick challenge: which partner would you use if the denominator were x plus y? We will answer that in the second example. Example: now the denominator is a simple sum x plus y with x equal to the cube root of a squared and y equal to the cube root of b squared. We are given the fraction a squared plus b squared over the cube root of a squared plus the cube root of b squared. Step 1. When the base is x plus y, multiply by x squared minus x, y plus y squared over itself. With x equal to the cube root of a squared and y equal to the cube root of b squared, that partner is the cube root of a to the 4th minus the cube root of a squared b squared plus the cube root of b to the 4th. Step 2. Apply the identity. The denominator becomes x cubed plus y cubed, which is a squared plus b squared. That cancels perfectly with the numerator, leaving only the partner factor. We can rewrite the first and last terms for additional insight. The cube root of a to the 4th is a times the cube root of a, and the cube root of b to the 4th is b times the cube root of b. Here is our first example. We will follow the same 4 steps you see on screen. Read the expression, multiply by a clever form of 1, collapse the denominator using the cubic identity, and finally clean up the fraction. Multiply by 1 using the cubic conjugate. For a plus b in the denominator, the matching factor is a squared minus ab plus b squared. Here a is the cube root of 5, and b is the cube root of 2. Multiplying top and bottom by that factor keeps the value the same. Step 2. Apply the identity directly to the denominator. The product becomes a cube plus b cube, which is 5 plus 2. Step 3. Simplify 5 plus 2 to 7. That gives 1 over 7 times the simplified numerator. Quick challenge: can you predict the cubic conjugate for a difference, a minus b? Now, a second example with a difference in the denominator. Step 1. For a minus b, the matching factor is a squared plus ab plus b squared. Multiply top and bottom by that to keep the value the same. Step 2. Apply the identity in the denominator. We get a cube minus b cubed, which is 2 cubed minus 2. Step 3. 2 cubed is 8, so 8 minus 2 equals 6. The result is the numerator divided by 6. Example. We will rationalize a denominator that mixes a sixth root and a cube root. Follow each algebra rule exactly in the given order. Step 1. Multiply by the conjugate of the denominator to create a difference of squares. We multiply top and bottom by the sum, sixth root of 3 plus cube root of 2. Step 2. Use the difference of squares in the denominator. The denominator becomes parenthesis, sixth root of 3 squared, minus cube root of 2 squared. Step 3. Convert the powers of radicals. Squaring a sixth root gives a cube root. Squaring a cube root gives the cube root of 4. Step 4. Eliminate the cube roots in the denominator using the difference of cubes trick. Multiply numerator and denominator by a squared plus ab plus b squared, where a is cube root of 3 and b is cube root of 4. Step 5. Apply the identity. The denominator collapses to a cubed minus b cubed, which is 3 minus 4 equals negative 1. Final step. Since 3 minus 4 equals negative 1, the entire fraction becomes negative the product in the numerator. That is our simplified answer. We will learn how to rationalize denominators with cube roots, exactly following the classic algebraic algorithm you see in many solution keys. First example focuses on 1 divided by the cube root of a minus the square root of b. Step 1. Multiply by a strategic form of 1, the cube root of a plus the square root of b over itself. This turns a difference into a difference of squares in the denominator. Step 2. Simplify. The denominator becomes the cube root of a squared minus b, while the numerator becomes the cube root of a plus the square root of b. Step 3. Now the denominator is of the form x minus y, with x equal to the cube root of a squared and y equal to b. Multiply by the sum of squares companion x squared plus y squared to create a perfect difference of cubes in the denominator. Step 4. Finish the product. The denominator becomes a squared minus b cubed. Keep the numerator as the product of the two factors. Let us do a second example that exactly mirrors the algorithm shown in many worked solutions. Here we rationalize 7 divided by the cube root of 3 plus the cube root of 4. Step 1. For a sum of cube roots, multiply by x squared minus y plus y squared over itself, where x is the cube root of 3 and y is the cube root of 4. Step 2. The denominator becomes 3 plus 4, which equals 7, by the identity for the sum of cubes. Step 3. Cancel the factor of 7 and simplify the cube root of 16 as 2 times the cube root of 2. First problem. Step 1. Multiply numerator and denominator by the conjugate, read as the square root of 3 plus the cube root of 2. This uses the difference of squares identity. Step 2. Simplify the denominator using the identity. The denominator becomes 3 minus the cube root of 4. Step 3. We still have a cube root in the denominator. Multiply by the expression x squared plus y squared, with x equal to 3 and y equal to the cube root of 4, so that the denominator becomes x cubed minus y cubed. Step 4. Evaluate the denominator. 3 cubed is 27, and the cube root of 4 cubed is 4. So the denominator is 27 minus 4, equal to 23. Quick challenge. Could you have predicted that the magical factor would be 9 plus 3 times the cube root of 4 plus 2 times the cube root of 2? Second problem. Step 1. Recognize the denominator as a squared plus b squared minus ab, where is the cube root of 2 and b is the cube root of 3. Multiply by a plus b to turn it into a cubed plus b cubed. Step 2. The denominator becomes a cubed plus b cubed, which is 2 plus 3 equals 5. Step 3. Simplify the fraction. Problem 1. We start with 1 over the cube root of 25 plus the cube root of 16 plus the cube root of 20. Rule. Expose the squared and product structure under cube roots. 25 is 5 squared, 16 is 4 squared, and 20 is 5 times 4. Step. Rewrite the denominator, highlighting the changed parts in orange. Rule. Difference of cubes factorization. For any x and y, x cubed minus y cubed equals x minus y times x squared plus x, y plus y squared. We will choose x equal to the cube root of 5 and y equal to the cube root of 4. Multiply by the special factor cube root of 5 minus cube root of 4 over itself. Using the identity, the product of the orange denominator with the orange factor equals x cubed minus y cubed, which becomes 5 minus 4. 5 minus 4 equals 1. So the result is simply cube root of 5 minus cube root of 4. Quick challenge. Can you predict the matching x and y for the second expression before we start? Problem 2 follows the identical structure. Rule again. Rewrite the terms under the cube roots to reveal a squared and a product. Apply the rewrite and highlight the changes in orange. Use the difference of cubes with x equal to the cube root of 3 and y equal to the cube root of 2. Multiply by cube root of 3 minus cube root of 2 over itself. The denominator times the orange factor becomes 3 minus 2. 3 minus 2 is 1, so the result is cube root of 3 minus cube root of 2. A divided by the quantity cube root of 49 minus cube root of 14 plus cube root of 4. Second, the fraction 1 over cube root of 4 plus cube root of 2 plus 1. For the first expression, notice a pattern. If we let x equal cube root of 7 and y equal cube root of 2, then the denominator becomes x squared minus x, y plus y squared. The identity says left parenthesis x squared minus x, y plus y squared right parenthesis times left parenthesis x plus y right parenthesis equals x cubed plus y cubed. So we multiply top and bottom by x plus y, which here is cube root of 7 plus cube root of 2. That transforms the denominator into 7 plus 2, which equals 9. Therefore, the simplified result is a times the quantity cube root of 7 plus cube root of 2 all over 9. For the second expression, set y equal to cube root of 2. Then the denominator is y squared plus y plus 1 plus 1. The identity says left parenthesis y squared plus y plus 1 right parenthesis times left parenthesis y minus 1 right parenthesis equals y cubed minus 1. So multiply numerator and denominator by y minus 1, that is cube root of 2 minus 1. Because y cubed is 2, the denominator becomes 2 minus 1, which equals 1. So the entire fraction reduces to cube root of 2 minus 1. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.